Okay, so we're going to continue with trigonomic graphs today. Let's review a few things we talked about last lesson. So I'm just going to write out the sine formula. And again, this is in your on your formula sheet. Okay, so my A from transformations, you would have called it the vertical stretch. It still is a vertical stretch, but another term we use in trigonometry is amplitude. And it's the distance from the midline to the max, or from the midline to the min. Okay. B, you would have called it a horizontal stretch. It still is a horizontal stretch. However, we can also use our B value to help us find the period, which for sine and cosine would be 2 pi over B. Our C value still just shifts the graph left or right. There's no new word that we use there. The D value still shifts it up or down. However, you will see this called the midline or sometimes the median. Okay, so this just reviews what we've talked about. You can use this formula to find the amplitude. To find the midline, you can also use the formula, except for there's an addition sign, so it'd be max plus min divided by 2. Period, you would use 2 pi over b or 360 over b, depending if your graph is in degrees or radians. Horizontal shift and vertical shifts, it's the exact same thing as when we did transformations. And the tan graph, I've listed all these details, but really all you're going to need to know is that the tan graph has a different period. Instead of 2 pi over b, it's pi over b. So that's really the only big idea we'll use from the tan graph. Okay, so let's start off by using our formula to identify these different characteristics of the graph. So we know the t value is our amplitude. We know this is the b value, which we use to help us find the period. It's not the period. The period is 2 pi over b. So then that means if my b value is 3, my period would be 2 pi over 3. Okay. My midline, in this case, is just that -4. It's always your constant. So it's -4. Okay, and then we have a vertical or horizontal shift, sorry. So we know our horizontal shift or our phase shift, okay, is pi units left. Pi units left, right? Because just like with transformations, your C value will always be the opposite sign, right? It'll always be the opposite direction as the sign. Okay. Now with our cosine graph, same thing. So our amplitude is 2 over 3. So remember, with amplitude, we always use the positive value. That negative, which if you remember for transformation, it denotes a reflection in the x-axis, but our amplitude will still be the same. Our period is 2 pi over b. Our b value this time is 1 over 4. So 2 over 1 over 4 is actually in fact 8. So my period is 8 pi. Okay, my midline is positive 3 this time. And my horizontal phase shift will be pi over 12 units to the right, right? Because it's the opposite as the sine. All right. So cosine, sine, you're doing the exact same thing. You can try this one on your own. The only thing I will caution you is make sure you factor out that 3 before you find any of the characteristics. Okay, the answers are online if you want to try it. All right, let's look at an example here. So this is a little more difficult than the questions we looked at yesterday because the midline isn't at 0. You actually have to figure it out. So there's multiple ways. You can definitely eyeball it and try drawing a line, which you think is the middle. I'm going to use that formula though. And I like to always start with the midline. That's just a preference. So I know my midline, if you look on that first slide, it's the max plus the min divided by 2. Okay, so my maximum is 1, my minimum is -5, divided by 2. 1 plus -5 is -4, divided by 2 is -2. So now what I'm going to do is I'm going to draw my midline at -2. So I'm going to take my pen and draw it at -2. There we go. Okay, and actually let's use that formula to find the amplitude too. So my amplitude is max minus min divided by 2. So this time I'm going to go 1 minus -5 divided by 2. 1 minus -5 is of course positive 6 divided by 2 gives me a positive 3. And my amplitude should always be positive. You can double check it here. If you were to draw a line, is it 3 units from -2 to +1? Yes. So my amplitude is 3. The period of the graph, now this is where it gets getting a little trickier. So again, I always kind of like to, and I'm going to use a different color here, kind of figure out where is it starting, okay, and then where does it start repeating? Right here. So that is 1 period. Okay, so if you look along that x-axis, I drew from 0 to 4 pi, which means the period is 4 pi. Okay, I'm actually going to skip horizontal shift for last here. So my midline was -2. Okay, so to find the horizontal shift depends if you're looking for a cosine or sine graph. So let's actually try both. We'll start with the cos graph. So I'm going to write that out. Okay, and fill in what we know. So we know the A value, the amplitude is 3. We know the B value, actually we'll have to figure that out. So my B value is 2 pi over the period, which is 4 pi. So then my B value has to be 1 over 2. Okay. And I'm skipping the C, and then my midline's -2. So my equation is going to look like this, and it actually will look very similar, cos and sine. The only number which will change is that horizontal shift, and I'm going to show you how we figure that out in a second here. So whenever I'm finding horizontal shift, this is the toughest concept in the unit. It's easiest to know where you're comparing to. So if you remember at the beginning of the lesson yesterday, we drew those original sine graphs and cosine graphs. So my sine graph looked like this. It started at the midline, and then it went up. Okay, my cos graph looked like this. It started at the maximum point, like so. So that's where you're going to shift from, is from that y-axis. So for the sine graph, I'm going to shift to the midline and make sure I'm shifting to the point in the midline where the graph goes up. So when I look here, and I'm going to use a different color, okay, here's my midline. So I start at the midline, and there's where my graph shifts, right? That's where the graph is on the midline, and I see it has that. It goes up and then goes down. So that's where I want to move that to the y-axis so it looks the same as my sine graph. So I need to move pi over 3 units to the left. So I'm going to go plus pi over 3. Sorry. I was looking at my cosine graph instead of the sine one. So I have pi over 3 units to the left. So you can see we just moved to the left, right? So we start at the y-axis and move to the left to get to that graph. Now with the cosine graph, I actually think the cosine graph's even easier. All you're doing is shifting to the maximum. So we know each of these little dashes is pi over 3. The reason I know that is because on the x-axis, there's 3 dashes to pi. So that means each one of them has to be worth pi over 3. So if there's 2 dashes to get to that maximum point, that means I moved 2 pi over 3 to the right. So I'm going to have x minus 2 pi over 3. Okay, and then when you graph this, you should see that your graph matches the picture. All right, so we're going to just discuss a couple of things here. Considering the graphs of the function. Okay, actually, I think I will skip this slide yet, and then just move to the last problem here. Okay, so this is a diploma question. It's a more tricky one, so that's where we're going to practice together. Or actually, no, this one isn't too bad. Okay, so it shows us the graph. It actually gives us the coordinates of the minimum point. So we know this minimum point is at pi over 2, negative 2. And a maximum point is at pi and pi 8. So find the equation of the function, okay, and we're finding a cos graph. So the reason that this question is not that hard is right away we know there's no horizontal shift, because do you notice how this cosine graph already starts at the maximum point? So that makes the question easier. There is no horizontal shift here. Okay, so let's start by finding the amplitude. And I would probably use that formula again. So my amplitude is max minus min divided by 2. So my max is 8 minus my min is negative 2. And of course, you're always using the y values. So 8 minus negative 2 divided by 2 gives me 5. So I know my amplitude is 5. My b value, I need to figure out the period of a graph. So here I'm at the maximum and go to the maximum. So my period is pi, right? Because I've traveled pi units along the x-axis. So if my period is pi, my b value is 2 pi over pi, which gives me a b value of 2. And again, there is no horizontal shift, so this question is fairly easy. Okay, so actually I'm going to rewrite it so it looks the same as the formula up here. So there's no horizontal shift, so really I just moved 0 units to the left or right. And my midline, which I'm going to draw here, and I'm going to write the formula for, max plus min divided by 2. So now I'll go 8 plus negative 2 divided by 2. 8 plus negative 2 is positive 6 divided by 2 gives me positive 3. And I can even draw it on there, and I like to draw it just so I can double check all my numbers. Okay, so then my a value is 5, my b value is 2, my c value is 0, and my d value is 3. Pretty straightforward. All right, so for the function, what are the values of a and d? This is another diploma question here. So remember, this is the range. It's not an ordered pair, right? These are both y values. So this would represent the minimum y value on the graph, and this 10 would represent the maximum y value of the graph. So if I wanted to find the amplitude, I would go max minus min divided by 2. So my max is 10. My min is negative 4 divided by 2 gives me an amplitude of 7. And if I want to find the midline, I would do max plus min divided by 2. My max is 10. My min is negative 4. Okay, divided by 2. 10 plus negative 4 is 6. Divided by 2 gives me 3. All right, so that's it for today. Again, the toughest part is definitely that c value. Let me know if you have any questions or need any help, and we will talk to you guys again soon.